major role to this communication. Same manner, these wearable technology is a very important topic to talk about IoT applications. So, if you want to do any wearable devices, you want to do deliver any wearable devices, or if you want to do a real research in wearable devices, people have to know what is actually happening, right? So, let me start with very basic fundamental questions. From that, we will start. We will go to the slowly move to the topic what I'm today planning to cover. Okay. So the first point what I want to talk is initially the communication was started from human to human, then human to mission, from mission to human, then mission to mission, right? Then various kind of information has been transferred between human to mission and mission to mission, mission to human, right? The way the communication has been started. Now the wearable technology is nothing but the mission, which is the device which is interconnected with our body, which is connected to any one of the base station or controlling station or host station. How to transfer the information from our body to the particular station, from that station to another person to know the complete setup of the information. There is a basic fundamental idea behind why wireless technology has came into the picture, right? While wearable technology has came into the picture. So if I wanted to send my information, the device should be attached with my body, but the device should not be harmful to my device, my body, right? So then only I can say it's a wonderful wearable device. So when you say this kind of wearable device, as a researcher, as a faculty, as a student, I wanted to know about what is this, how it is working without affecting my body, right? So that information should be very clear before going to the directions and the innovations of the particular topic. Okay. So what I'm trying to explain is initially we should know first of all what is the human being voice frequency range. What is the human being voice frequency range? Anyone in the group? Human being voice frequency. See, I'm talking, right? I'm talking. What is the frequency range of my vocal point is vibrating in order to get the voice? What's the frequency range of the human being voice frequency? Can anyone say this range of frequency? It may be correct or wrong, but people have to know, right? That's what I'm asking this question. Yes? Yes? What is the human being voice frequency range? Remember, this is very important, okay? 300 to 3400 hertz. The human being voice frequency is 300 to 3400 hertz. Why I'm saying this is the initial point where the communication has been started, okay? So that is the reason we are taking the voice frequency bandwidth is 4 kilohertz. When you're going to do a sampling, it will get 2 into 4 kilohertz, will get 8 kilohertz. When you want to quantize that 8 levels, 8 into 8, 64 kilobits per second is needed if you want to send your voice signal through your digital system. If you want to send any voice signal from one person to another person, I need 64 kilobits per second. Why I'm saying the same way, a device which is connected in my body, I need to know what is the minimum bandwidth needed to send this information from one point to another point, right? So, which frequency you are going to send, whether it is ISM band or Wi-Fi or WiMAX, which band you are going to send, where it is going to be located, which point is exactly it will useful to transfer this information from our body. It should collect properly. That is that what do you call that? Selectivity and sensitivity should be very high. How it is going to be working, right? So that is the ultimate idea of this particular lecturer today, right? So that's what I am planning to do now. Right? And moreover, the people have to know about what is SAR. People know what is SAR? SAR. People know what is SAR? Yes. So these are the main terminology people have to know when you're going to start to work on the wearable technology, right? Yes. What is the minimum power needed to receive your mobile phone? You have a mobile, you want to receive the call. What is the minimum power needed to receive that particular call? We are saying that, right? If I'm not connecting the call, what you will say? I don't have tower here. Meaning is the power strength is below the level of the power which you needed to transmit, which you needed to connect the call, right? That is the reason we are saying that there is no tower, right? What is the minimum power is needed to receive a call? You go and check it in your mobile phone. Go your mobile phone setting and go and see your about your phone. There you can see minus 80 dBm. Minus 80 dBm is the minimum power needed. If it goes minus 81 dBm, then your mobile will not receive any call, right? So up to minus 80 dBm signal power, the mobile. So why I'm saying all those things are similarly, if you design any wireless system, wireless technology or wearable technology, you should know each and every point how it performs, where to where it's communicating, up to what distance it will communicate. All those information you should know. Then only we can start to work on this particular case, right? Okay, so that is the reason I will keep on asking some questions to know it. Okay, so this is the way you need to know, right? So when you say the wireless technology, the other very important parameter is antenna. Without antenna, wireless technology is completely failed, right? Wireless and wearable devices are completely failed. So the antenna sensitivity and selectivity should be very high, and that antenna power should be very low. Because if the power is very high, your device will take a lot of power. Within a 1 hour, 2 hour, your wearable devices will lose all the energy. If the power is very less, then what will happen? You have a high durability, so the device you can charge another two days once or 4 days once, right? So the power should be very less, but the selectivity and sensitivity be very high. All those parameters are connected with your antenna. Even though you have very good communication system in the wearable technology, wearable devices, you need a very good antenna. That is nothing but a transducer which converts electrical signal to electromagnetic signal if it is sitting in the transmitter side, electromagnetic signal to electrical signal which is sitting in the receiver side. That's the fundamental characteristics of how antenna is working. But the antenna should reduce only very low power, right? That's the main ultimate, right? So when you're going to start about this, the first thing is what is antenna? We should know what the definition of antenna according to IEEE and why we need to design antenna. Well, that's what I said. A wearable antenna, wearable device, if you want to work, I need antenna. The antenna should be very small. The size of the size of the antenna, which is lambda by 10 or lambda by 15, we call it as a miniature antenna, right? Smart antenna, right? So those antennas are needed. But if it is very small size, miniature size, automatically your gain is very less. The meaning is the antenna which is integrated in the wearable device is not possible to transmit a long distance because the gain of the particular guy is very low, right? So that is the reason you need to take care of all those things. Then you have to start to design your wearable devices. Right, today I am planning to cover what is microwave, what is the microwave basics, antenna fundamentals, types of antenna and their application, and comments on microwave. This is the first part of my presentation today. Then the second part is it purely talks about your wearable devices. What are the wearable devices are there? How it is going to be useful, right? Okay, right. So when you say fundamentals, these are the parameters you should know, right? What range of frequency, which band you are operating your wearable device. If I'm working at ISM, that is 2.45 gigahertz. If I'm working Wi-Fi, that is 5.2 gigahertz, and 5.4. There is another band also, sir. So there is a different band. So I need to know frequency. Then directivity. Directivity is focusing on a particular direction. Directivity. Antenna efficiency. That's what I said. Antenna efficiency should be very high. If antenna efficiency is very high, the power efficiency is also very high. So the efficiency is moderate over here, especially in terms of wearable devices. Then if you're going to talk about antenna gain, I already said the gain of the antenna will be very less in terms of few dBi, right? It's not more than that because the power consumption is very low. And wavelength, what is the wavelength that I said, right? Minimum the size of the antenna, which is connected, which is integrated in your wearable devices is lambda by 10 and lambda by 15 the range. And polarization is very important. There are three types of polarization: linear polarization, circular polarization. In circular also there are two types: left-handed circular polarization, right-handed circular polarization. Whereas another one is elliptical polarization. There are three types of polarizations are there. Which type of polarization we are going to use? Generally, what are the commercial wearable devices? Notice this is a very important point. Wearable devices, all the wearable devices generally, commercially usable wearable devices, they use circular polarization. Right-handed circular polarization they will use because the orientation of the antenna, if you're going to change, the power will not be get suppressed or the power will not get interfered. That is the reason they will use circular, right-handed circular polarization they will generally use. And all your dish antenna, what are the antennas you're using in your home, all are circularly polarized. That is the reason during the heavy rain time, your antenna will not receive the signal, right? Because the rain droplet size and your antenna, which is working, will connected with satellite or match, the wavelength are going to be matched. So it will give a highest level of electromagnetic interference. So automatically your antenna will reduce the power performance. That's the reason why the your antenna, which is sitting in the top of the roof, is not working during the rainy season. Okay, so this is the polarization. So these are the main parameters has to be decided, has to be known properly before you are going to integrate any kind of antenna in the variable device. Right. So what are the types of antennas? All these type of antennas are the final one. The traveling antenna is a baseband antenna, large periodic antenna is a baseband antenna, and then aperture antennas are the baseband antennas, wire antennas, reflector antennas, array antennas. I am talking about the last one, planar array antennas. Okay, so the planar array antennas are the antennas which are used to integrate with the wearable devices, because this is the only fellow you can design in terms of 2 dimensional compared to all other antennas are 3 dimensional, and the physical size is very much big. I will call it the bulky, right? But whereas the planar antennas are two-dimensional antennas, and the antenna is very easy to fabricate, very easy to integrate, and it is another beauty of this antenna is very low power consumption antenna, right? So that is the reason we always preferable for planar antennas. People may know, or I'm not sure about that. If you go to 2 decades back, if anybody is calling your home, you have a receiver. In the receiver there is a antenna, aerial antenna is there, right? You have to open up and then you have to talk. Once it's over, you have to close that, right? Have you observed that? So you need to take it out like a radio. You have to take it out and then you have to talk. It's nothing but a monopole antenna. Then you have to close. The meaning is that this is a three-dimensional antenna. It is not possible to integrate with the PCB. So the remaining all of the antennas are, it is very difficult to integrate with the PCB. In order to overcome that, we are keeping that antenna on the outside. So this drawback has been overcome by using the planar array antenna. Planar array antenna is the one which is used to integrate along with the PCB what are the devices which is going to be connected to us, right? Okay. So next very important point is there are 10 commands of microwave. When you say microwave, you have to be very much careful because you are dealing in some gigahertz frequency. So you have to be, even it is 1 millimeter or 0.1 millimeter, it creates a lot of electromagnetic interference, right? So in order to avoid that, you have to be take care of all those points. These points are very important before you're going to start your research. See, when you're designing an antenna, when you're designing a variable devices, checking in the simulation part, you will get proper response. But if you want to go to the lab and you're doing a application, you're doing testing, definitely it will get a lot of interference. Why? Because you should be take care of during soldering and during fabrication and during precision. Fabrication precision is very important. Similarly, your device has to be tested in a proper calibrated equipment, right? So that is very important. So the experimental setup is very important. People who are dealing in this high frequency range. So that's the reason I'm saying. So these are some fundamentals when you talk about in terms of frequency, what is the wavelength of that. So why we are moving? See, in terms of gigahertz, 3 gigahertz only 10 centimeters, we take 30 gigahertz, the 1 centimeter, right? So 1 centimeter is a 10 mm, right? The distance is only 10 mm. So if the frequency increases, the wavelength is increased. That's what I said. We are playing near to the 3 gigahertz, right? Near to 3 gigahertz is 2.45, right? 2.45 means around 10 centimeter. I said lambda by 10. So what you get lambda by 10 means automatically it will come below the 1 centimeter. So automatically the size of the antenna which is integrated in the device is very small, right? So that is the reason why I have chosen that ISM plan, right? So before going to the wireless device or wearable devices, these are the basic fundamentals where the information has been shared between the devices, right? So initially we started with the single wire. So you can see the figure A is single wire element. So in the single wire, the source and load are connected using single wire. There is a lot of crosstalk. In order to avoid the crosstalk, the figure B as well, it's nothing but a twisted back cable. Using this twisted back cable, you can see this one. The third one is two-wire shielded pair. Okay, two-wire shielded pair technology has been came in order to overcome the bandwidth. Then you have a two-wire ribbon flat create, right? So that is also another methodology. But these two are same. In order to go for continuous flat plate, they have some ladder type arrangements called a parallel two-wire line. Then the complete microwave RF system has been ruled out by using the coaxial cable. Till now, all the applications we are using the coaxial cable, right? Because it has a huge bandwidth and high power handling capability, right? So that is the reason we are always focusing in the coaxial. Then you have a waveguide, right? Compared to coaxial cable, waveguide have a huge bandwidth. It acts as a high pass filter and it will generate a huge amount of power. You can send a huge amount of power wherever you want to send a signal from base station to satellite. You need a huge power because it has to travel long distance in terms of some thousands of kilometers, right? So that is the reason you need to spend a huge power, right? Well, let's say from ISRO, they are tracking the satellites using the radar. They need to send. If we want to pump a power to the radar, we need a wavelength, not coaxial cable, right? So those applications they are using, and then optical fiber is the advanced one. Is another way of communication in terms of optical. So these are the technology has been revolved where it started, where it's going to be ended up, right? So that's the reason I am showing this all the communication devices between the source and load, right? So this is the same way. What are the things I discussed? From this, we are much interested in the microstrip line, right? The microstrip line only we are going to use this in wearable devices. Remaining all these things are not difficult, very difficult to connect it over here. The microstrip lines are useful to connect the antenna which is located in the wearable device and your source, nothing but your modulator or signal transmitter. Between the signal transmitter and the antenna, using microstrip lines, it has been connected over here. And energy transfer, this is a very important topic. We wanted to say about energy transfer. There are three main areas are there. One is the energy generation, next one is the energy transportation, next one is the energy consumption. Why I am taking this is, let's say I am having some wearable device which is connected in like a wrist watch in my wrist. What information it has to receive? It has to receive from my body. So that is a transducer. So it receives the signal from my body. It will convert to the electrical signal. That electrical signal is processed in the device. Then the processed information is given to the antenna, which is connected in my wearable device. Then that information is transferred to the nearest node or nearest person. What is the information actually acting in my body, right? So this is the main ultimate block diagram of a wearable device, right? So those areas, I need a very good energy generation, energy transportation, and energy conservation. If these three parameters fail anywhere, your information is get malfunctioned, and that the information you will not get the proper information to process on it, right? So that is the main advantage of what is the reason behind the energy transformation. Okay, right. So the next one is going to be where it has been started, where you are going to be. This is a basic fundamental again. When you talk about in terms of circuits, only in terms of power, we will talk about transmission line, coaxial lines, and waveguide optical fiber. All we are talking in terms of pointing theorem, right? Without pointing theorem, you can't able to point. Why I am again pointing theorem bringing into the point is how to find out power of each and every point. Let's say I have a wearable device which is connected in my body. I wanted to transmit that information to another guy who is sitting 5 kilometers away or 1 kilometer away, 2 kilometers away. This device is capable to send the power up to that particular guy. How I can find out? Using the pointing theorem. If I know pointing theorem, that is the meaning of pointing theorem is at that particular point, what is the amount of electrical intensity? What's the amount of magnetical intensity? If I'm taking cross product of these two elements, I will get the power of the energy, electromagnetic energy in that particular point. Can you get my point? What I'm saying? Pointing theorem is nothing but finding the power of that particular point. What is the power? That power is enough to receive the signal or not, right? So that is the reason why pointing theorem is there. Even in your BTEC electromagnetic fields, the people are talking electromagnetic fields. Without pointing theorem, you can't find any question, isn't it? Yes or no? Without pointing theorem, because pointing theorem is very important to find out the point each and find out the power each and every point of the free space where they are finding the power with the help of pointing term, right? Okay, let's say I have a tower. Okay, I have a tower which is sitting at the origin of the particular point. With the radius, after 5 kilometers, they will check the point at that particular point. What is the power? If the power is below minus 80 dBm, then they need to install another tower. If it is above 80 dBm, then they will increase the radius of the tower. Then again they will increase. Where the point is below minus 80 dBm, there we need to keep the another tower. This is the way the installation person will come, but they don't have any idea about that. He will come and he will check each and every point what is the power of the signal. If the power of the signal is below minus 80 dBm, then he has to install one more tower over there. Why? From that they came to know that the power strength is very less compared with the mobile what is going to be received. So we need another tower over there. So how I'm know that there is a power is less by using the pointing term. So that's why I'm saying pointing term is very important. How the pointing term he calculated with the help of the at that particular instant what is the amount of electrical, that particular instant what is the amount of magnetical. Using these two values, they are taking cross and then finding what is the power which is presented over there, right? So this is the way how to check the power of that. Similarly, For our case, I am talking about our case. Our case is wearable devices. So the wearable device has to transmit the signal. When it is transmits the signal, as I said, the antenna size is very less and the power also very, sorry, energy gain is very less. When the gain is very less, the transmitting distance also going to be less. So I need to check it any particular point if I want to receive what is the power. If I want to know what is the power up to what distance a particular wearable device will transmit, I need to check with the help of pointing theorem. That is the reason why I am bringing the pointing theorem over here. Okay? Yes. So I have a wearable device in my hand. After 500 meter, I need to check what is the power. After 1 kilometer, I need to check what is the power. After 1.1 kilometers, I need to check what is the power. So where at what particular point, if the power is below minus 80 dBm, then I came to know that that is the power, that is the distance that particular wearable device is working. If you go beyond that, you can't get the signal from the wearable device. So that knowledge has been get it with the help of the pointing theorem. So that's why I'm bringing back all the basic fundamental concepts in order to build your wireless technology. Similarly, when you talk about this kind of energy transformation, so how the circuits will work? Okay, in the circuits will work as a inside connector. In the circuit, the signal will transmit inside the connector, whereas the transmit line, coaxial lines and waveguides, which is transmitting in terms of EM and TEM modes, right? People know about what is TEM, what is TE, what is TM, but that's why I'm not going over in depth. If you wanted, I will explain in the end of this section. But my intention is not to explain about what is TEM and TE and TM. So just I'm skipping. In the final, if I find the time, I will explain what is then how to find out what is the importance of this mode transformations, all those things. People those are good in transmission may know about that. But anyway, if you wanted, I will explain about that also. Okay, right. I will go to the next one. So when you go high frequency, these are the effects. When you go when the frequencies keep on increases, these are the problem. But if you are not increasing the frequency, the antenna size is very big. If the frequency is high, this problem will come. If the frequency is low, the problem will not come. But what will happen? The size of the antenna is very big. That size of the antenna is not possible to connect in the possible to integrate in the variable. So that is the problem. Why I need to use this high frequency antenna arrangements in order to enhance the efficiency or radiate the information to a long distance. So if you're going to use a high frequency range, what will happen? The very first important point, people will know about that. Scaling effect will come to the point. The second one, the transition time will be there. And moving electron introduces the current, right? You keep on increasing the current, frequency transmission is come, and delay will be there, okay? And retardation radiation is there that you people are studied in the antenna fundamentals, and phase reversal of the field, displacement current, and cavity. These are the problems when you want to increase the high frequency effects. Okay, so this effects will it's not possible to reduce, but by using this effects we wanted to increase, right? So that is the basic fundamental behind this, right? So the next very important point is people wanted to work a wearable, a wonderful, efficient wearable device. You have to be take care of these three parameters. If you are failed to take these three parameters, your wearable device will not work properly. It's a very important point. People wanted to work, wanted to test in real time, wanted to use the real time applications of your wearable device. This three parameters forms a major role. But if you're going to design in a system, you can't find these three parameters. You can't check these three parameters. But once if you are fabricated, if you want to do a experimental validation, these three parameters will come into the picture. The very first one is mainline loss. The term mainline loss talks about between your modulation block and your antenna, there is a transmission line. There is a transmission line, right? Between the block, is nothing your source and your transmission line, antenna, you have some line which is connected between the antenna and your source, right? So it's a main line. So it will take some loss. There is a loss when it is going to transmit it from source to antenna. So that has to be reduced, right? That has to be taken. What is the loss begin there? Because there is a coupling. We call it the cyclic couple. Only in the edges it will radiate. It's called the bridging effect in your antenna. Also you have effect. So that is your main line loss. Second one is insertion loss. Insertion loss is nothing but due to your soldering of your SMA, your coaxial cable. So the coaxial cable consists of some loss, right? Some connecting loss is there, soldering loss is there, angle loss is there. So all those things are comes under the insertion loss. The last one is coupling loss. The coupling loss is nothing but the antenna who is sitting near to the source will also act as a coupled between the source and that is nothing but your modulator. Okay, your transducer, modulator and your antenna will couple and it will create some loss. So it's called as a coupling loss. But these three losses you can't find it in a system where you call the terminology in your software itself. But if you're going to do a real-time application, you will find this problem. So these are the types of antennas pictures. So the very fundamental and basic antenna is wire dipole antenna. The second one is loop antenna. The third one is wire monopole antenna, right? So these are the very fundamental, basically low power and low efficiency antennas. Whereas if you go to talk about Yagi array and horn antenna, these antennas and corner reflector, parabolic reflector, these antennas are very powerful, three-dimensional, high gain and directive antennas. Whereas this microstrip antenna and slot antennas are planar antennas. As I said already, these antennas are low power, low gain antennas, and these antennas are helpful to operate in the low power and medium distance applications with the low gain, right? So those areas they will use this kind of antennas. And this is the complete setup of what are the types of antennas are there, where it's going to be plot. So this tree will give a clear picture about that. Okay, so when you talk about antenna, these are the complete classification of antennas. But our wearable application will fall under the slots, patches, and arrays. You can see here. There is a fourth arm. You can see the slots, patches, arrays. These are the antennas has been integrated over here in the what do you say, in the wearable devices. Whereas other antennas are useful for some say, high power and some base band applications, but we are planning and focusing only this area, right? So these are the antennas mostly useful to do a wearable technology application. Okay, right? So this is one of the example of the planar antenna. Just I'm showing you here, but these are the different types of and different geometrical structure of planar antennas has been used. And this is wearable planar antenna. People can see how the size is going to be. Right? See this one is flexible devices. Lot of flexible devices are in the market. It is available for wearable application alone, and you can use this in the you can do a conformal conformal arrangement, and what kind of angle or you want to change the orientation of the substrate. Everything is possible in market. Lot of substrates are available to check and perform. And if you have a very good wearable devices, only wanted to interchange the antenna, you design an antenna and check it over there, and it will transmit in the real time in the experimental setup, either in the indoor or outdoor, wherever you wanted to check it out. So you came to know that how your antenna is going to be work, right? So that is also one of the possibilities which is there to utilize in the advanced level of wireless communication system. Okay. Right. So now I am going to till now I am talking about the microwave part. Now I am planning to move into the your wearable devices. When you say wearable devices, there are a lot of wearable devices are there in the commercial, and a lot of companies are commercialized companies are there to give a lot of devices to use to do a lot of information to gather from the body, right? So mostly the body area applications they will use this, right? So this is in terms of business, it creates a very wonderful level of what do you say market devices are available, readily available devices. So I'm starting with a very simple devices are available in the market. So if we're going to talk about the factors in the wearable technology today, we wanted to say the response should be very fast. The device has to collect the information from the body. It has to process to in the wearable device, and it has to transmit by antenna. And the particular guy or another node should be reviewed properly. Then it has to transmit to the another person who wanted to review this all this information. So the response should be faster, very much faster, in terms of some milliseconds or microseconds. Then the hardware is very cheap, right? Initially, if you go to talk about 2015, 2016, 2017, if you buy a smartwatch, the cost is around 15,000, 20,000, right? 20K to 15K. Nowadays, 3.5, 3K, you are getting a lot of smartwatches, right? So the hardware is cheaper than cheaper compared to the 9, 10 years before, right? And the cold storage, the information is stored, and that is also possible. Location of data is possible, okay, and self activity is possible. Gaming industry is there, right? So these are the different way how the wearable devices has been improved in terms of technology, right? So these are the some factors I'm going in. Not only this, lot of points are there, but something I gathered, and I'm presenting here to understand the importance of wearable technology over here. Now, I am planning to cover broadly in a four ways. The first one is devices. What are the devices are there in wearable, and what kind of inputs the wearable devices will work? Then, what are the applications which is available? Then, algorithms. So, what are the algorithms are needed in order to create a beautiful wearable devices to work perform to perform its operation. Okay. So the first thing is device. We'll see devices in detail. Then we will go inputs. What are the inputs are there that we will check, and then what are the applications which falls, and then algorithms, right? So we will see one by one. This is the outline of the presentation. In the second half, I'm talking about, right? So devices. When you want to talk about devices, what are the devices are there? Audio video capturing devices. Generally, when you say information, people we are very much familiar. One is voice information, another one is video information. The next one is text. Like that only it will go, right? So these are the different devices are there to capture the information, right? So I can say audio video capture devices, right? So this is one of the example of how Google Glass works. I'm going to talk about smart glass. So you can see here there is a battery, and you have a CPU that is also integrated over the glass itself. Then you have a wonderful camera which will be useful to take photo as well as video. Then you have a visual overlay. Then you have a microphone. Then you have a speaker. So all those things are integrated in the Google Glass. Right? Then in a specs you can see all those things. So it's nothing but it's one of the wearable device, and a smart device. I can say it's a smart glass, right? Small smart specs, right? So see, this will keep on capture the information, and it will give a, I will process as well as the information which is transferred with the help of CPU to the other guy. In the CPU itself, there is the what you call antenna is there to transmit the information. Then and there, what are the ways you are getting? Whether you are getting a voice signal using the microphone, you want to receive a photo or video using a camera. All those things are collected, and it is being processed with the help of CPU, which is transferred to the adjacent node to receive the information about that particular wearable device, right? So this is the one of the example I can say in terms of devices, right? So see battery also there, right? So the CPU, microphone, camera, speaker, or delay, all those things should contain very low power. The power level should be very low. If the power level is very somewhat high, it is very difficult to manage to give a supply using battery, right? So that's why you need to confirm that the information should be very sorry, the devices should contain very low power. So the another way, another device, the person who wanted to fix the camera in the neck, so they can receive the information from the in front of him, right? So the another device which has been familiarly used everywhere to review the information. So this is the next one in order to get the sensors, right? The first person camera with the sensor and the GPS also will be there. So then and there, if the information is viewed with the help of camera, it has been transferred using GPS arrangement. It is transferring to the next level. So here it is integrated with the sensor, and the GPS will also be presented. So this is people always know about audio capture. It's nothing but audio with the automatic audio capture. It's not a watch, okay? It's not just smart watch. It's a wrist audio capture, okay? So only it will receive the audio signal from the wrist watch, right? So that is the another important one kind of the devices used, and then body data gathering devices. So what are the devices we have seen, which is connected in the, which is weird in the body. If you wanted, you can use and you can remove it and keep it somewhere. But whereas this one, it is body data gathering devices. So we want to gather, that is nothing but health monitoring applications. We want to see the status of the health monitoring, those areas is used. So this is nothing but a health monitoring. So that is a rechargeable battery up to 10 days of use on a single charge. That's the beauty. So the meaning is what? The meaning is what? That the compound which is connected, right? The compound which is connected on the device is very low power consumption. That is the reason they are saying that up to 10 days of use on a single charge. Okay, once you charge it, you can use 10 days. So its the size is 3.5 mm plug, and then it is water resistant. So these are the different types of monitoring the health activity, which is connected. Which is, you can connect this in the wrist, right? Right. So this is another one, fitness tracker. So it will keep on monitoring. So people are always nowadays using this. It's nothing looking like a watch kind of things, and then it will completely monitor the entire day. And you can interconnect this to your mobile phone also. So the mobile phone and your antenna, which is present in the wrist watch also, fitness tracker also connected together. Once it's connected, the data is transmitted to the phone. You can see in the phone app what is actually happening over here. Another type of smart wristwatch. This is a smart wristwatch. What are the watch we are using nowadays, right? So this not only showing your timing, also it will show what is the distance you are traveling, what are the so you know it, right? So these are the minimum criteria needed if you want to measure your body activity, monitoring the body activity. Okay. So the next one is EEG. It's advanced one. People wanted to use emetio brain activity called as EEG, not ECG. EEG. It is useful to check the vibration of the neurons. People have more than 200 crores of neurons in our mind, right? So it will be very useful to measure the vibrations of the neurons. See, people know about that in your home. Ladies will always remember the points, even you talk about that particular promise 5 years before, but gents will not remember. Did you know what the reason? You know what is the reason? Ladies always remember if you promise something, she will not forget. Ladies will not forget, but gents will forget. What is the reason? Do you know what the reason began? It is related to your scientific reason. Ladies will always remember, let's say your father or mother or anybody's husband and wife. If you say any promise to your wife will not forget that. Your mother will not forget, but father or husband will be forget what he has said 4 years or 3 years before. But she will not forget, she will remember. What is the reason? Began that there is a reason in a scientific reason. That's why I wanted to say that. Why? Because ladies have a huge length of hair. So what will happen whenever they are combing? Whenever every day morning they are combing, what will happen? The neurons which is present in the brain, it starts to vibrate. When it's vibrated, the memory is increased. The memory will be regained, renewed. But whereas gents have a very small length, right? They will not comb first of all. Even they combing, it is you are not giving a pressure on your head, right? Once if you are not giving a pressure on your head, your neurons will not be vibrated in your head. If it is not vibrated, what will happen? Your memory will not be regained. That is the problem. But if you go 100 years before, that is the before the British has ruled our country, both gents and ladies have a huge length of hair. So both will comb, and at that time the memory is very good. That's why till 12th or 10th, if you go check, all the ladies will get good score compared to the boys. The reason began that is they have a good memory. How the memories come? If you keep on recharging your neurons, you are renewing your neurons, but it start to vibrate. Okay, when it will vibrate, when you are giving putting a pressure on the scalp, right? So when the pressure is very high, automatically the memory will be regained, right? So that is the reason ladies have a good memory compared to the gents. Why I am giving the same way, if you want to check the activities of the neuron, the activities of your mind, or anything you wanted to check, this EEG device will be very helpful to give an input. Okay, so that's the reason I'm giving some input over here. The next one is brain monitor. Again, you wanted to monitor brain activity. That's what I said here. The same thing like EEG. It's a commercialized one, but whereas this is used by the doctor, and they have some procedure to keep in your head, and where you have to keep, where you need to check that particular point, you need to use some pressure. So there is a current is there. Nothing but a sensor. There is a sensor which senses the activity of your brain, and then it has been given to your system. Then you came to know what is actually happening over there. Similarly, this is the commercialized one. You can connect any one of this smart with your laptop or iPad or mobile, wherever you wanted, you can connect it and you can check it out how it performs, right? So it's the commercialized one to check the brain monitor, how the brain is working. If you want to check that, they are using this kind of arrangement. The next one is going to be smart shirt. Okay. Okay, so the next one. So it will give a very clear picture about what are the things you wanted or what is actually happening over here. Okay, so those areas just a minute. So this is another wearable device. It's nothing but a smart shirt. So one of the example I'm showing. So you can check it out how the stress level. Some information about your body you can get it by using smart shirt also. And then you have a smart shorts. Okay. So short. So this will be helpful. I will show the clear picture. This is the way. See where the transducer sensors are sitting in the bottom of your shoe. So there, based on your pressure and your activities, it will gather the information, and then from that information you came to know what is the your body activities are, right? So those areas are there. But anyway, wherever the devices are there, without the antenna, it's not possible to do any communication over there, right? And then sensor. The main component which is presented in the wearable is one is sensor. The sensor should be properly calibrated and properly designed. The second one is the transmitter and the processing device. So only these three devices are available with the help of battery, right? So this is a very important one of the application of the wearable devices. So the next one is printing the technology. So you would have some nanometer size. You can print in the body itself, right? Like a tattoo. So we call it as a flexible variable sensor. That you have the way that the sensors are flexible. You can adjust it. You can see in this picture, the third picture you can see, you can adjust on it. So you will completely monitor your health. So this will be another kind of sensor which is used to operate properly, and then you can get it. But this is harmful. But directly, if you keep in your sensors, all the devices printing like a MMIC, monolithic microintegrated circuit is printing in your skin. So it creates a lot of health issues. But this is the one way I am showing you here, because shock absorption rate is SCR rating is very high. If it is very high, that information that electromagnetics will also passes in your body, so it creates a lot of it leads to cancer also, right? So that's the problem. But anyway, this is one of the way how the health monitoring technology has been moving towards the easiest way to provide, and you can't find where it is printed or not also, right? So those applications they are using on it. And then the next one is recognizing devices. What are the recognizing devices are there? So this is the one muscle activity tracker is the one device, and then you can see the smart ring is another device. So different ways how the wearable devices are there in the body to check the monitoring the performance of the body. Okay, and then the smart ring, where the smart ring is going to be, what where to you can what are the things you can do on it. Right, so that also you can see over here. And this is something about health and heart rate, you can ECG, right? So the another one, another device blood pressure, all those things you can check on this. And then it is the display. Okay, as a display, see, you can see in the bottom of this area, you can see some arrangement. It will give us some light as well as you can display. You can touch on this, automatically will change based on your pressure. The pressure which is coming out from your finger, and based on that you can select which option you wanted. So the another one. Again, this will create some skin problem, right? So the another way of your wearable device. And then wearable discussion research paper. What are the ways of wearable devices are there in the research? Till now, what are the points I discussed in the basics and already available in the commercial? But how the your wearable device is moving towards the a new next future? Okay, we can say in the future how it's moving on it. It's only what in terms of research papers. I wanted to give some glance about this. So wearable devices are visualizing knee rehabilitation exercise. So what it will do? It will physically measure the performance of the knee once you are doing some operation on the knee. Another 1 month or 2 months you want to do the signal from when you're walking or running or sleeping different times, how it performs, which is the data which is collected from this system is correct or wrong with respect to your the already normal person, right? So the data will be compared, and then the information will be gathered from this kind of device. This advanced research is going on. In 2023, one of the paper I found this, and then I wanted to just give you some plans for you. Just a minute. Right. So when you're going to talk about the classification of wearable devices, you can classify into two categories. One is creation wise and another one is function wise. So in the function wise wearable devices, life longer you can use this gesture recognizers, entertainers, video gaming and assistant, right? So in terms of creating jobs, emergency jobs, right? So for the based on the function, you can classify it into two categories. Just a minute.
Sir, do you need any short break, sir?
5 minutes, ma'am. Shall we go for
Yeah,
5 minute break? Then I will
yeah,
start again.
yeah, sure, sir. We'll stay tuned in that same link, sir. You can
Fine,
take
ma'am.
a 5 minutes of break, sir.
Sure,
Please
sure.
relax yourself and come back, sir.
Yes, ma'am. Thank you.
Thank you, thank you. Participants, please stay back. We have a short, break for 2 to 3 minutes. Okay, sir will be joining us very shortly.
Shall we start now?
Yes, sir. Yes, sir.
Okay, thank you. Thank you. So this is function-wise wearable device classification, whereas this one is creation-wise. So replacing daily wearables with the smarter activities. It comes under watch, shirts, shoes, socks. So these are the devices we have discussed till now. Then creating new wearables, right? So this is not the headband, shirt, clippers, right? So these are the new wearable devices, and a lot of research is also going on this particular area. So people are interested. You read literature on this particular area, and you can get some drawbacks as well as what are the things you wanted to improve on it. Okay, so in terms of armband, headband, shirt clippers, all those areas are open research problems are there. To integrate more information and using a single sensor, so you would want to multi input connecting sensors are there. So using the sensors, how you can get the data without affecting the texture of the body. Okay. So input. So up to now we discussed about the devices. So what are the types of inputs are there, right? So when you talk about inputs, so as I said already, it's a sensor, variety of sensors, lighting sensor, accelerometer, and then magnetometer, biometer, okay, thermometer, relative humidity. So all those things are comes under the inputs because these are the main devices to collect the information from the body. If this devices, the sensors will provide a malfunction, the complete wearable device become a malfunction, right? So in order to get the proper device, right, we need a beautiful sensor. So the sensors plays a major role in order to get the information properly from the body, and it has been processed in the wearable device and it has been transmitted using the antenna. So I can broadly classify a block three blocks. One is inputs and another one is the device which is processed the input. That is nothing but the sensor output has been processed in terms of power, in terms of noise reduction, in terms of calibration, all those things. Then it has been given to the antenna. Then antenna will be transmitting over the space to the connected devices. So nothing but EEG sensor. Already we have seen this physical activity sensor. So what will happen? You can measure, you can monitor what is actually happening in your body. So it's nothing but the MC10 series sensor, right? It is huge amount of cost when you're going to be buy this MC10 series sensor. But some other sensors are also there for laboratory purpose and the research purpose. You can buy and then you can use that to check how your wearable device is working on this particular area, right? So it's nothing but a physical activity sensor. Then traditional inputs and captures. Okay, so these are the some traditional inputs we can say. One is audio. It's nothing but it is a one kind of transducer. It's nothing but audio microphones, video, photos by using camera, head mounted, body attached to smartphones, and Wi-Fi, cellular, GPS. All this comes under traditional inputs, right? Because people are what are the commercial devices, wearable devices you are seeing? All the commercial devices are working with the help of these inputs, right? So that's why it's called as the traditional inputs and captures. And then when you're going to talk about applications, so these are the some applications. We already discussed the same again. I'm gathering over here. Google Class, you have seen narrative clip synchronous with the cloud, and then gathering some summary from the video and audio or image is important on the important problem. Automatic daily creation for the users and talking notes of available users is important. This one is the information is completely gathered and it has been processed by in the processor, including the processor. It's called as active wearable devices. It's called active wearable devices. Whereas the devices commercially we are using and we are connected in the finger, ring, and the wrist watch, all those things are not active. It's a passive one. So what it will do, just it will collect the information and process it as it has been transferred to the device. Right. So if you want to further go to collect the information and create a comparison between the data, so day by day, we need active wearable devices. Those applications also you can use. And activity tracking. What are the ways activity you can track each and every day, and you can store that information 1 month or 15 days or 1 week. Those areas also you can see. You talk about that's what we have seen the lot of apps also. Every 2 hours once there is a alarm to find out the to drink the water level, sleep patterns, the steps walked every day, detecting eye contact using wearable eye tracking glasses, okay, eye contact, and then wearable activity recognized by the dogs. So all those things are the a very a wide range of applications are connected together in a single device. It's called a smart wearable device. You say a smart wearable device more than 10 to 15 works, 10 to 15 level of monitoring is going to be there to monitor in a single device, right? So it's nothing but activity tracking each and every day, and then health care. So what are health cares are there? You need to check the calorie count and using multimodal wearable sensors, wireless health, all those things are comes under the health care monitoring levels. This is the very important compared to what are the applications we have discussed, right? So what are the applications we discussed compared to that? Healthcare is very important, and moreover, this information then and there it has been transmitted to the nearest node or who is connected to the device is connected to them, right? So using this only you came to know that how the body behavior is going to be, right? So this is a very important wearable application, I can say, right? And then the next one is this one is not useful for each and every day, but some applications, somebody is working in a harmful organization or in companies, those areas are very important. But other than that, in the commercial way, there is not that much needed one. And then you wanted to assess, right? So those areas also you can use in biometric like your system, authentication systems, smartphones, wherever some security purposes are there. So those areas it will assess as to check the person is correct or wrong, right? So those areas which have been useful, and then assess the special people, right? Special people wanted to assess to where they are, where they wanted to go by using GPS location also. But GPS have some approximately 3 to 9 meter deviation. But GPS located algorithms are you can generate, and using that you can use some input to the special people to guide them to travel or guide them to get any what are the data they wanted, right? So those areas also this will be very helpful for assisting the special people, reading the newspaper or walking for daily needs. Okay, for the daily needs, based on the needs of the special people, we can design a wearable devices to help them to perform their daily needs. Okay, and the reliability talks about very important because we once you started about the wireless VR devices has to be very important is selectivity, reliability, and sensitivity. These three parameters play a major role. If these three parameters tested, then only you can send a particular device or inverted one to the commercialized, right? So that should be very much important. And in India, Chennai, Samir only they are doing this. Center for Electromatics, Samir in Germany, they are doing. That's the only place you can check your wearable devices how it performs, right? So that is the setup. All the commercialized person also they are sending there, and then they are doing all the calibration testing. Once they are giving the certificate, it comes under government of India. Once it's certificated, the devices go to operate, then only it is useful to send the commercialized one, right? So that those applications, those areas are very important. So you need to be very much careful when you're designing a wearable devices in terms of reliability, right? And algorithms. What are the algorithms are needed to enhance the performance of that hardware device? We know that always what are the devices are there, everything is driven by the help of algorithm software, right? Now the software is moved to the AI, right? We have initially with the help of electrical, then we went for the electronics, then we trusted in from electronics to some coding, from the coding to we went for software and algorithms. From the algorithm we have went for the AI. So that's next level of technology has been moved over to based on the AI. But the general flow is future selection extraction should be there when you talk about algorithms, noise removal and smoothing, and the peak detection and filtering, and unsupervised. Then nothing but a K means EM maximization. All those things are considered again. SMA method or LDA method you can use to fine tune the device how the performance is going to be. In order to enhance the performance of the particular system, we can use this kind of arrangement over here, right? So it's a general flow concept as this, and they need better sampling algorithms. As we already said, in this case, we need to sample by using the sample algorithm. That one is very important because uh, 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 maybe some device will create a malfunction because of the device orientation or the selectivity of the particular compound which is used to fabricate the particular wearable device. So those areas are very important, especially in the body networks as well as the healthcare monitoring applications. So it is very important to properly verify that the particular device is calibrated properly. right? So those areas are we need a sampling algorithm to perform properly. So the next one is robustness for the context awareness, activity readiness. So the healthcare wireless health 2012 paper tries to find the dynamic time wrapping technique to perform the moderately. And nowadays a lot of papers are came, but anyway, what is the reason I'm giving these are the I can say these are the fundamental papers, fundamental articles which helpful to know the basic fundamentals about the what is actually happening, how it performs in the wearable devices. So that's the reason I'm showing these two articles over here. And then needs to customize machine learning algorithms nowadays, right? Now slowly moving to the machine learning and AI. So there we need to do a customize, and you can read this kind of books also. So it will be very helpful to further enhance your research area. And then this is very important. So wearable computing and smartphones, how you are going to be connected your wearable computing to your smartphones. Most common observers, you can say apps connected and storages, Bluetooth, Wi-Fi, direct, all those things are connected with your wearable devices. Right? So this is the way how your wearable devices are connected to your IoT. Right? So that's what I said. In the very first point when I started this presentation, I said wearable devices is nothing but it's a kind of it's a one type of IoT, right? So we wanted to connect all the things in the Internet of Things so that you came to know what is actually happening in the device or what are the device, what are the things it's measuring. Everything will be gathered together. Okay, so this is another way of wearable computing and smart home. And then wearable computing with the gaming applications, wearable computing with the search, and computing with the social. So these are the different applications I can say when you talk about wearable. And the wearable wherever is connected, the very first one is wearable is connected to smart. That's what we know it very well because every day people are using this, right? So the next one is computing to the IoT application you can use and computing with the smart homes, right? In order to check the performance, lighting, or all those things you want to switch off or switch on the devices in the home if you are out of the home. So those areas and computing the games, right? Virtual computing game environment, people are playing on that. And then search, you want to search something you are missing, right? So those areas also it is very useful. Computing social media, right? So these are some applications I can say. Similarly, multiple wearables in synchronize. The meaning is multiple wearable devices are synchronized with the single device, like this, right? So there is a multiple wearable devices are there. One is body bus and the anchor is there, IR tag reader is there, 802.11 bridge is there. So all are connected together in a single body to perform to know it what is actually happening, right? So this is the MIT Media Lab. They generated the new kind of wearable device which is connected together. You have a n number of wearable devices in the body. All are connected to a single way of transmitted to the adjacent node, right? So you can see where camera is and how it's going to be controller, how you can see. So all those things are comes under the wearable devices, one of the applications, right? So this is also one of the application of wearable device. And in Google Glass, again, I'm talking about Google Glass only because this plays a major role too. This is one of the Google Glass type, right? Initially, they have been introduced this. So from this, how it performs, so all those things you can get it over here. And in terms of privacy is very important because the data you should not share everyone. So in order to get that, we need a mobile app to connect the wearable devices to mobile app so that using the mobile app you can control the wearable devices performance and you can check the data, everything, and it will not be sent to the other person, right? And if privacy and security will come to the same category. And the energy, as I already said, the energy consumption will be very, very low. And that energy will not transfer to the body. That's very important. Given that the energy consumption is high or low, the electromagnetic signal which is generated in the wearable device in the sensor, it should not be penetrated, it should not be traveled towards the body. If it is traveling towards the body, it creates a lot of problem in the biological system, right? So in order to avoid that, we should not allow us to travel over there. Okay? So that's another important one. And then the institution is a very important one. So based on the person, based on the data, the need of the wearable device will change, right? So initially only one data is enough for getting the information, but future it will change. So you can customize that. The wearable devices should be customized based on the input needed by the customer, right? So that application also has to be integrated over here, right? So when you talk about new ideas, as I already said, these are some new ideas, and also finding the EEG, right? Commercializing EEG, and which is connected to your smart devices, electronic gadgets is the one of the method, and then you can generate the books, right? You can store the books in smart devices. Whenever you wanted, you can read by using your free hands also, right? So there are the new ideas which is comes under you can try with the Google Glass and smartphones, right? And the mental health suggestion. Everywhere they are using this kind of application for here, right? So when you're going to talk about the next one is the computer-based systems, right? Those are applications also you can use by using these devices which has been connected to your printing computers, right? So these are the new ideas which have been currently going research in the wearable devices, right? So up to this is my presentation. People have any doubt you can ask now. Yes, I'm giving an overview of the wearable devices. But you have to do some fundamental paper in the literature. You came to know what is actually happening. Based on that, you can build your research work further. Okay. So this is my presentation today. After this and topic, people have any doubt, you can ask now.
Thank you, sir. Participants, if you have any queries, please ask sir.
Participants, if you have any queries, you can clarify with sir. Otherwise, we will be sharing his mail ID for further clarifications. Do you have any queries, or we'll wind up the session? Participants can post their queries in chat box also.
Yes, multiple wearable devices may produce radiation, but we wanted to orient the device radiation towards out of the body, not inside the body. That's very important because the device which is connected to the body is needed to send the information to the node, adjacent node where you wanted to connect it, right? But if you're going to you design a system which is going to be send the radiation into the body, it will create a biological effect, right? So that's called SAR. Okay, SAR should be as much as low. Like that, you have to design. If the SAR rate is very high, automatically it creates a lot of skin effect, tissue effect. You can get some cancer effect also. So in order to avoid that, the person who is designing a wearable device, the person who is designing an antenna, which is integrated in the wearable device, should be outside of the body. It should be properly sealed towards the body. Only the sensor should be towards the body to receive the inputs from the body, and it has been processed in the device. Then it has to given to the antenna. The antenna should radiate the outward of the body, not inside of the body. So what I wanted, the antenna should be radiate in a particular direction, a radiative antenna, directive antenna, not towards the body, right? So I need to do a proper shielding because proper shielding is somewhat difficult because it's a variable, it's a flexible surface. When the flexibility is there, it's somewhat difficult, but you have to do some shielding using FSS. Frequency selective surfaces are there. Using the frequency selective surface, you can shield the antenna properly to avoid the radiation inside the body. So that's possible. That we can do it. So like that, we have to be designed when you're designing any kind of wearable device. So then I can say it's an efficient one. You just check the recent literature about the wearable devices. What is SAR rate? Okay. How long after what time period it will affect your body? That also you can check. And you try to give generate a new kind of innovate a new kind of wearable devices should be higher than the value of what already proposed. Like that also you can go ahead. I think I have clarified your doubt. People have any other doubt, you can ask. Yeah. Gate variables again.
Yes.
I didn't get your question. I don't know. Reddy Sunil, you asked one question, but I didn't get it. I'm not clear your question. Sorry. Can you unmute your mic and can you ask this question? Hello.
Dear
How do we-
participant, your voice is not audible. Can you please just a bit louder
No.
to ask a question?
No, he's asking that how many days we can use. You can use the n number of days. If you have any problem on the device, you wanted to check the device, you do every 6 months one calibration. There's a lot of calibration places are there. You can calibrate. That's what you can do. A experimental validation of your wearable device, or else you do you buy a commercially available wearable device. From the wearable device, let's say you're designing an antenna. You remove the antenna already available in the wearable device and interconnect your antenna. You check it how it performs. Before me, you check how your commercial antenna is working. Now check it your test antenna is going to be. Like that, you can check how it's going to be work on it. What are the recent research areas in wearable body? A lot of researches are going on, sir. Lot of researches are going on. When you talk about the wireless body area networks, in communication part, research is going on. Sensor areas, research is going on. Antennas, research is going on. Energy, in terms of EEE department, EEE is working about the battery, right? So you need a battery size is less, but the storage amount is going to be high. The weight it should be very less. So a lot of research is, I can say 4 dimensions. One is energy, another one is communication network, which you have to communicate, which path it has to take, or what kind of antennas has to be used. Antenna research is going on, and your sensors. Sensors is a huge topic. You can find a lot of papers in sensors. IEEE sensors, you can see a lot of papers. Sensor applications alone, it's a separate journal which is going on. So that is one of the main area. You said there are 2 places in China in performing wearable sensor project. Can you specify in it? No, actually, it's not a project center. It's a Government of India Center for Electromagnetic Summit. If you are designing a wearable antenna, wearable system, wearable device, you can test that how the performance is going to be in indoor as well as the outdoor. Samir Center for Electromagnetics. You designed a complete set of wireless wearable device. You wanted to check the performance. You can go there and you can approach there. You can send a mail. Within a 15 working days, they will give you some slot and you have to pay some money. You go and test your device, how it performs, right? And then in indoor, both the cases you can check. In indoor means in the attack chamber environment, they will check. If you are in outdoor means in the free space, they will check. First, try to check in indoor. If it's past that testing, that experimental validation, then go ahead in the outdoor, so that you came to know what is actually happening over there, right? So that is the idea I'm giving. There is no any project at all. You have to design. You design by yourself. A lot of tools are available. You design and you fabricate. You go and test over there. You came to know what is actually happening. Or else people have a different what is it? Diverse peoples are there. Ask them to design sensor one part and then system one part and then antenna one part. Communication people all together put together. You write a proposal also in a DST also. You can get, because a lot of research is going on in wearable devices. So that's what I can say. And then you go and test over there. That is the one way it is going to be useful for you. Nodes in body area network which are present along with the sensors. Again, process across the relay node. Relay node is low speed. The speed is very low. So don't use the relay nodes. You go some other sensor, some electronic sensors are there. To just do some literature, you came to know for the past 2 years, 23 and 24 articles, some referred journals, IEEE journals. Go for do some IEEE journals regarding the census. Don't go for relay. Relay notes, it will take minimum 5 to 7 seconds to respond. So that is huge delay when you're talking about wearable devices. You have to wait. You want to check any output or any input to process, it will take 5 to 7 seconds, not milliseconds, 7 seconds. But actually what we wanted microseconds, not in milliseconds also. So relay is not good. Relay is using in railway signal changing. When the train is moved red to green, green to yellow, if you want to change those areas only, they are using this. Okay, but you should not use this. Don't use relay nodes, especially for body area network. Use some other network, some other sensor. It will be helpful, and you can your paper easily will accept it. The acceptance ratio will be increased if you use any high speed sensors, right? So that is what I can say. Any questions? Do you have any questions?
Participants, any other questions?
So if you have any queries, kindly ask sir, or else we can wind up the session. Okay. Thank you, Dr. Patsari sir, for your valuable session. From the basics, I was started and clearly explained about different types and its effects, different types of losses. What are the things which you have shared is everything is useful and much informative. And you have covered the recent trends also. It was very interesting and shared about technical places where we can access and all. Thank you very much for your wonderful presence and support, sir. Thank you very much.
Thank you, sir. Thank you. Thank you for. I wanted to thank the organizer, and I will be very happy to here to deliver my lecture. Thank you. Thank you so much, sir.
Thank you, sir.
Thank you.
Dear participants, the links will be shared in the group. Kindly fill both links, session 1 and session 2, and come back tomorrow in the same link sharply by 6 o'clock. Thank you and good night.